Welcome to your Newton online class. In this particular class, I want us to study a topic in mathematics, and that topic is set theory. Now, before we dive into the discussion, what do you mean by set? In this context, a set simply means collection of items that are well defined. For instance, items of similar identity. Like here, a collection of mathematics teachers, that Mathematics Teachers Association, that's a set. A collection of football players is a set. So a basket containing fruits is a set. In a library, we have a set of books and so on. So in this mathematics here theory, we use figures. We can use figures, that are numbers, numerals. We can also use alphabet, that are letters, to identify collection of items in a set theory. Now let us look at basic notations in set theory that will guide us in the study and calculations. We have this symbol x element A. This means that x is an element of A. That is, this symbol notation here means that x is an element of A. Then here, this cancellation here, this slash here, shows that y is not an element of B. By element of a set, we mean those components, those family members of a set. Then here, the symbol like mu, that is u, or like e, these are Greek symbols, notations used in set, they are symbols. This one looks like e, this one looks like u. It symbolizes the universal set, that's the mother set, the basket, the family household of the set of the items defined. Then, when you have zero cancelled, like symbol face, it means the null or empty set, a set without anything inside it, like an empty basket, empty house. Then when you have empty set like this, these symbols like bracket used to denote a closure of a set. Then we don't use zero for empty set because zero can represent an item in a set. Then we have A like inverted C like this. We call it A union B. The symbol like that, not U, it's like inverted C, A union B. Then A union means that collection of all the members of that set. That is, A is now a subset of a member, B is subset of the same family member. When you join them together, call family meeting, you have A union B. Okay, then A intersection B. Intersection B, that's the symbol here, like N, but not N. That symbol simply means, the intersection means the members in A and members in set B that are the same, what they have in common, that is their intersection, their common factor. Okay, then A prime, this symbol up here like dash, A prime, simply means A complement. And what do you mean by that complement? It means all the members in the mother set, in the household, in the family, in the entire household that are not part of family of A. So all the items in the universal set, in the mother set, that A is lacking, that is the A complement. That's what A requires to be like the universal set. We shall see it in the example. Then here, this is A subset B. That is, A is a subset of B. A is begotten from B. Then, if you invert this now, because that means that B is a superset of A. Then, M bracket A simply is number of elements of A, number of families, number of family members of A as a household. That is it. Now, without wasting time, let us look at a typical example of set so that you understand this language we are speaking here. Good. Look at the question on the board. We are given universal set to be whole numbers less than 10. We are given a subset A to be prime numbers less than 10. And another subset B to be even numbers less than 10. Then we're going to ask this question because the question will come in symbols. That's why you should know the notations. We are asked to find question I, A union B. Question I, A intersection B. Then question I, A complement intersection B. You see the difference between this and this. A prime, A complement intersection B. Then question IV, A union B bracket open and close complement. A union B bracket open and close complement. Now let's quickly solve this question. Now, for us to solve this now, in solution, uh, for the want of space, we shall make use of this to interpret these statements quickly. What do we mean by whole numbers less than 10? By whole numbers less than 10, we simply mean 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are whole numbers less than 10. Then now, prime numbers less than 10. We can put them here. What do you mean by prime numbers less than 10? A prime number is any number that has two factors. Only one and itself can divide into it without remainder. So think of those numbers out here. They are 2 is a prime number. 2 is the only even number that is prime. Then 3, 5. Another one is what? 7. Remember, 9 is not a prime number. 9 is not a prime number because 9 has more than 2 factors. By prime number, we don't mean odd number. Not all the odd numbers are prime number. But all the prime numbers except 2 are what? Odd number. So 9 is not qualified because 9 has more than 2 factors. 1 can divide 9, 3 can divide 9, 9 can divide 9. So this one says even numbers less than 10. Then we think of even numbers less than 10. Then from this family, this smaller set, even numbers less than 10, 2, 4, 6, 8. So even numbers are numbers divisible by 2. So this question is meant to test your primary knowledge of all these numerals, number categories. Okay, now this is what we have been given to us. We have interpreted the question. Now let's solve the problem. For I asked us A union B. A union B simply implies this is like bracket, but write it well, not a bracket. A union B, we look at from explanation I gave here, that is combine the family members of A and B. A and B are subsets of the universal set. A union B, join the families together. But see the rule, as you are joining them together, there will be no repetition. So you have join them together. Anyone that appears 2 times, take 1 as a factor. So let's go. We have here 2. We have 2 and 2. So we take 1, 2. Because 2 has answered present. We have what? 3 in the order. We have 4. You have 4 before 5. Then we have what? 5. We have 6. We have 7. We have 8. So you see. So you join them together. But anyone that occurs 2 times, like these 2, you take 1. And then you arrange them in sequence. So that's it. Then I asked us to find A intersection B. By A intersection B, we mean what they have in common. Look at the family members of A, family members of B. What they have in common is the intersection, their common factor. You take it. A intersection B, we have A intersection B. We look at what they have in common. A, we can see 2 here, we can see 2 here, so they have 2 in common. Okay. Is there another thing they have in common? No. So that's all. So A intersection B, settled. But what if there is nothing they have in common? If they have nothing in common, then you leave it as empty set. Don't write 0 inside because 0 is an identity set. It's a property. So you leave it as empty set. Or you use the symbol null set. That's 0 cancel. Okay. Then we are proceeding. I. We have to find A complement intersection B. Not the same thing with this. A prime. First of all, you look for A prime. A complement. Let us manage this place for our A complement first. So A complement should be what A is lacking from the mother family, from the larger family, that the household, the universal set. What A is lacking. So what is A lacking there? From here, this is A is lacking 1. A doesn't have 1. That's A complement first, before we look at the joining here. So A is lacking 1. From here and here, we compare these two, A and the mother set. A is lacking 1. A has 2. This one has 3. The A is lacking 4. The one is A lacking again. A has 5. A has 7. A is lacking 6. The one is A lacking again. A is lacking 8. And the A is also lacking 9. So this was in like A complement. See how to justify your work. Count the digits. So it must balance with this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 1, 2, 3, 4, 5, 6, 7, 8 to 9. So that shows that you have done your work well. So A requires this to be like their modern family. Okay. Now the question says A complement intersection B. Quickly, what are we judging now? We are judging this A complement versus what? B versus this. So we are judging these two. We are judging these two for this question. We are judging these two. So A complement intersection. What do they have in common? That's intersection. We match them together. We take them. So here, B A complement has 1. No 1 in B. 4. There is 4 here. They have 4 in common. 6 here. 6 here. They have 6 in common. Then 8 here. 8 here. They have 8 in common. This one has 9. This one does not have 9. So they can't marry. So this is the marriage between them. That's their intersection. Then IV says A union B complement. So A union B complement. This is prime. So what do we need to do here? What are we judging here? Look at A union B, settled already. Look at A union B. So you are judging A union B, then what they like from their mother family, from their family background. That's the universal set. Universal set. I use the language mother family for your understanding. The universal set. Because all these people are like this is like a Jara family. This is like a man from the family and his household. And his household, this is the Jara house. So what A union B complement means what A union B is lacking to be complete like their mother self. So look at A union B. So we are judging these two, this and the mother self. We are judging these two. We are judging these two to get this. Okay, so A union B, there is 2 here, there is 2 here. A union B is lacking 1. So they need 1 to be like the universal set. They have 2, 2, 3, 3, 4, 4 is here. They have 5, 5 is here, 6, 6 here, 7, 7, 8, 8. They are lacking 9. They don't have 9. So 9. So I think this is what they have. This is what they need to be like their mother family. Here we separate this with commas, commas, commas. So look at it now. Count. A union B, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is complete, like 1 to 9 here. So this is what we need to do to attend to this question. So I believe with this basic example on set notation, explanation, and this application in this question, you have understood the key concept or the hint or the basic concept of set theory, and you can now use it to solve simple problems involving set theory and set notations or symbols. So in the next class, we are going to look into a Venn diagram. Venn diagram. So we are going to solve problem that involves Venn diagram by next class. Thank you for attention to this particular class. And for more of this solution and the lectures on mathematics and physics, you can reach out to me through my phone number here. You can chat me on WhatsApp. Then you can join me on YouTube channel or Instagram or Facebook page. If you need extra classes like online classes in preparation for JAMB, WAEC, and NECOM, GCE, NAPTEP, you can contact me for online tutorials through Zoom, Skype, Telegram, and so on. Thank you so much. I remain your tutor and friend here.